So good to be here at Tech Field Day. It's a real honor and privilege, and I'm very excited to share some of our latest technologies with you in the IoT space. So what I wanted to cover, well, actually what I've been covering the last little while with our Tech Field Day presentations is to align to our BU's priorities. The first is leading with the network. So the last two Tech Field Day sessions, I was really focused on the networking, the routers and the switches and how we ruggedize them or make them heavy duty or put them into hazardous environments and all the re-engineering that takes place on that. In fact, the last Tech Field Day session that I did on this was a direct result of Ivan's question, and Ivan's not here. I thought he was going to be here today. I was like, oh, well, he asked a question when I was here last time in January. It's like, I said, well, we basically re-engineer these routers and switches from the component level out all the way to the shell and the casing and everything and make them shock and vibe, electromagnetic resistant and all these other things. And he's like, how? And so that, I didn't have a really good answer at the time. So I did, couple weeks of research and put together that next Field Day, Tech Field Day session that we covered at San Diego. But today I'm going to pivot and address our next two priorities, which is differentiating with security. And then finally, we're going to be talking also about delivering value from data. So that's what I want to cover. We're going to talk a lot about, oh my goodness, my thing is jumping all over the place. Want to overview the OT threat landscape. This is a little bit different from the IT threats, and these are very specific and targeted and very expensive attacks. So I'm going to overview what that's all about. Then I'm going to introduce something that we launched just yesterday, which is Cisco Cyber Vision, and what that brings to this specific problem area. And then we'll do some demonstrations of that. And then there's a really cool development too in the software-defined access space that I just want to introduce you to as well. It's called Policy Extended Node. What is it? How does it differ from what we've been doing already in that space with Fabric Edge or Extended Node? And what's the additional value add there? And then pivoting over to edge data. What are the challenges with dealing with data at the edge? And what are some of the tools that now, again, we've just launched that help you meet those challenges? Does that make sense? Okay, so let's just briefly, how many people are familiar with OT technology and industrial control systems, or should I do a little bit of a recap there just to set some context? Okay, great. So one of the best ways that I like to compare or use an analogy for IoT is if we compare all of our digital technologies to our human bodies, which we're all familiar with, compute resources, very much analogous to our brain. That's where we do all our thinking, processing, memory, everything. But IoT is very akin to our nervous system. That's what interacts our brain, an abstract entity, with the physical world around us. That's how we sense the physical world through sight, sound, touch, smell, all these other ways. And then also how we interact. We can actually cause change and move things around and do things in the physical world, all via our nervous system. Well, that's what IoT is all about. And so we have these things that are sensing physical elements, anything from cameras or microphones, but in industrial, usually they're sensing pressure, in some cases, humidity, salinity, or anything else that they're monitoring, and then they report that. But then also we have things that can actually cause physical change, moving things around, compressing machines, doing this, that, the other thing. So all of that collectively is called OT. So at the bottom of it, we have these things that sense or take in information or actually do something based on a signal that's coming from a computer somewhere. These are the things in the Internet of Things. And then there's millions and billions of types, or millions and billions of things around. They're estimating 50 billion devices within the next 5 years are all coming online, and these are the types of things that are doing these functions. Now, all of these are in turn controlled by local computers. So industrialized computer systems, you might have heard the term programmable logic controllers. These take inputs and then send outputs to the devices according to whatever the program has been done. And then these might also be distributed systems if you're controlling multiple of them, et cetera. In turn, the next level of hierarchy are these supervisory systems that control groups of these programmable logic controllers or these local computers that in turn control the things. So there's a hierarchy. At the lowest level, we have the things that actually interact with the physical world, the local controllers, and then higher level controllers. After that, we would have an industrial data center. It would be segmented and separated from the IT. You want to keep all of this as segmented and separated as possible for the purposes primarily to drive security. There would be interaction. There would be some types of communication to the overall the overall enterprise IT networks, because it's a company and the information, there's always reasons that there's information flow requirements. And then ultimately you separate and you got your DMZ to the general internet. This is an older model, the Purdue model. It's been around for decades. And what we're seeing is a lot more blurring now of these strict levels of segmentation, especially as digitization, as IT systems and policies are being controlled at the lower levels. But it's a very traditional model, very common in this environment. Not only that, but there's a lot of industry best practices as to zoning, saying that divide your production lines into cells, and highly recommended that those cells be segmented. Now, while that's recommended, it's actually very rarely implemented. In OT environments, traditionally what we have is just people that run very large, flat, layer 2 networks, just keep adding device after device after device. And they're very susceptible to broadcast storms. A lot of multicast traffic can even bring that down. There's a lot of there's nothing stopping lateral communication, and that really presents a challenge. So the key points to these two slides are, there are industry guidelines that recommend layers, hierarchy, segmentation, and so forth, but overall, it's not always implemented. Now, what does that lead to? Well, we're all familiar with IT attacks and cyber attacks. They've been around for decades. But OT attacks against these particular types of systems we've just talked about, are only about a decade old, just over. The first of which was a famous attack called Stuxnet. It was a nation-state attack against the Iranian nuclear program. And what's very interesting about it is that all these Iranian nuclear centrifuges, these machines that spin around and then separate and separate elements, et cetera, that are critical to the nuclear process, they spin around and they're controlled by these programmable logic controllers. And the instructions from the malware was basically telling the controllers, spin them faster until basically they literally rip themselves apart. 1 in every 5 Iranian centrifuge was destroyed by this attack. So that's really, it's an ominous thought to recognize that there can be attacks that cause physical damage that are originated in the digital world from malware. This is just a phenomenally new and scary concept. Now, what's particularly interesting is that the centrifuge systems were all air-gapped. And the thinking was, well, as long as we air-gap our systems, they're completely secure. But this isn't so, because what happened here is that the malware was spread via a USB that was given to one of the 5 vendors that were related to this program. We don't know the specifics because, again, this was a nation-state attack, so there was a lot of covert elements to how it was carried out. But basically, that malware was spread through a USB via one of the vendors coming in, and then it actually leveraged 4 day 0 vulnerabilities in the Microsoft operating systems, and then attacked Siemens programmable logic controllers, which then just basically issued a command to the centrifuges, spin faster, until they just tore themselves apart. So, a very scary attack. It was followed not too long by another nation-state attack. It was presumably Russia attacking the Ukrainian power grid. And there's actually videos of this on YouTube of these people in the control room that they don't have any control over their systems. And they're going, what's he doing now? Referring to the attacker, because the attacker is just shutting this down, shutting that down, and they're just completely panicking. And over 200,000 people are left without power as a result. Again, some very physical world consequences from a digital attack. Now, this is now spread into industry as well. So for instance, just a couple of years ago, as one key example, Merck Pharmaceuticals, one of the largest pharmaceutical companies, was hit by NotPetya, type of ransomware that really wasn't holding data for ransom, but was very specifically targeted to interrupting production. They estimate, the latest estimates of the losses for this attack is 1.3 billion. Because when you attack and disrupt operations, that's where the companies make their money. That's what they do for a living. You know, when you get an attack that's IT related, it's about data loss or breach, or sometimes ransomware, holding data for ransom. But there isn't the same level of impact on the company's production as these type of attacks, because that's what you're looking to disrupt. What does a company do to make money? Okay, I'm going to stop them from doing that. Earlier, well, not this year anymore, but last March, the world's largest supplier of aluminum, Norsk Hydro, was hit by an OT-directed attack. And again, their production shut down for 2 weeks, and the latest estimates of that attack are 75 million. Last month, there was an attack that we don't have a lot of details on, but it shut down a US port. And again, it was an attack that came in and through the IT systems, probably some type of phishing, and then spread over and was targeting industrial control systems so that they couldn't load containers. It even shut down and took control of all the video surveillance systems and many other things. So basically shutting down a port. And you can do all this now through digital cyber attacks.
I see also in the evolution of this, there are now specialized ATP crews just aiming for that. They know already how the IoT networks are structured, how they get in, and at the beginning, I think it was more a widespread attack against anything.
Yeah.
And now getting narrow and narrow, and specialized crews, they exactly know how these networks are structured, are digging into that, and that's why we see also an increase in attacks.
Yeah, and also you need to add on top that all the tools that are used for attacking are getting more and more sophisticated, and they require less and less knowledge. So actually anybody can just start jumping on it and immediately just click buttons and try it. And well, if you don't have the security, then everybody's exposed and, well, you're done.
And I think the last point, just adding here, if you have a bank, for example, this is built maybe a banking network with a mindset of security. Mm-hmm. This was built for industrial needs, not with the security in mind. Yeah?
That's absolutely, and I'm going to come to that, because a lot of these systems and protocols, again, they weren't built with security in mind because it was never a concept, and they were built and designed decades ago, and they've been running as they have been for decades. But listen, guys, thank you so much for getting the conversation ball rolling. Do you have one of these books already?
No.
No? Okay, well, I've signed it, and I wanted to give you one too, Daniel. You guys, it's so much more fun when it becomes interactive, so I just wanted to express my appreciation on that. Okay. And these are very valid points. These systems were never designed with security in mind. A lot of the communication on these networks is clear text, you know, and it's like, okay, and even the instructions, like we talked about sending instructions from a PLC to a device, whether it's a centrifuge or anything else, it basically just sends the variable, and it looks like a legitimate transaction, and you just change the one single variable in the communication. And so even if the policy allows for that communication to go forth from the PLC to the end device, the specifics of the communication are what cause the attacks, not some abnormal flow or from a different device. So how would you stop or prevent that policy? So some very interesting observations, and I'm going to address all of them. And then finally, I know you guys don't like analyst quotes, but there was an analyst that quoted that about 40% of cyber attacks now are targeting operations. So this is very much a shift in focus, because this is where you hit the company where it hurts. And so we see this on the increase significantly. Like I say, it's only about 10 years that we've been seeing these type of attacks, and now definitely a shift in focus on these threat actors. Very, very, very good comments. So that then sets me up to talk a little bit about what we just released yesterday, Cisco Cyber Vision. And so in this space, here are some of the, we're familiar with the requirements in IT. And in IT, we've been dealing with cybersecurity for decades. And we're constantly patching our systems. You're always being pushed for a software update and all these things to try and protect your devices and your security posture. The IT attacks are more easily identified because of the worms and the types of patterns. And so we see them, and we can, once we're identified, we can detect them and then prevent them and then set the policies. In OT, though, we have very different requirements. For example, even the word, when we start talking about security in the OT space, their first thought is, oh, security is dealing with people's safety. It's not, network security or data security. It's about safety. They're very resistant to software upgrades. They have their machines and software running, and if it ain't broke, don't fix it. And they've been running that way for decades. So you see very, very old systems, Windows XP, Windows NT even sometimes. And so it's very difficult to protect an environment that is so rife with vulnerabilities and resistant to upgrades. And then finally, as I just mentioned, the attacks themselves don't look like worms. They don't look like virus. They look like legitimate instructions. Instead of spinning that centrifuge at 30 RPM, spin it at 75. Well, it's a legitimate instruction from a device that's allowed to send that instruction to the other device. So how do you know that this is actually harmful? And identifying that is very important.
It's a little bit comparable if I remember the shift from traditional telephone systems to all over voice over IP. Then the whole people that were designing these networks, there was a learning curve to know how to, let's say, secure also IP-based telephony.
Yeah.
In this space, there's still a lot of room. The people need to get the right mindset when they build a new facility,
yes,
that this needs to be secured and that it is a real threat when their production is down. Yeah, so to make the awareness is kind of super important.
That's such an important point. And there is a lot of knowledge that needs to be transferred into the OT space, because they're just dropping in network devices, and network connectivity like as cheap as possible. And it has no security. Or even the IoT devices themselves. They typically have the thinnest IP stack possible, again, for cost. And virtually no security on it whatsoever, and it's like they're just exposing themselves. But in that space, they've never had to deal with this type of thinking, and so that education, that awareness, hey, you have to know about network and security and best practices. So there's a lot of knowledge that needs to be transferred, actually in both directions, because the OT needs to learn about all these best practices about network and device security, but then vice versa, IT really doesn't know a lot about what happens in these production environments. Like, what's a protocol named Profinet or Modbus or OPC UA or any of these other industrial protocols, and what do they do and how do they work and what is actually happening down there? It's a different area. So these teams really need to work together. And it's not even just a technological problem to solve, it's often a cultural one. Because they've been separate for so long that there's a great deal of resistance and starting that collaboration. So there's some specific challenges. In fact, we did a Master Series video yesterday on bridging the gap between IT and OT that was specifically addressing the cultural challenges. So very good comments.
Well, with what you were saying earlier about how the lines are blurring between the IT network and the OT network. When you've got the OT looking for these things that they're vulnerable to, and IT looking for those things that they're vulnerable to, and there's no meeting of the minds, then both sides create a vulnerability vector for the other.
Yeah,
so
you're absolutely right.
You've got someone coming in, bypassing all the known stuff on the IT side and accessing the OT side through the IT side because nobody saw it coming.
Yeah. Very good, very relevant points. And then there's also sometimes mistrust based on, well, I can't work within your framework. Like OT will say, perhaps, I can't wait on the phone for support and then be passed around from one person to another while my production line is down. That's costing me hundreds of thousands, if not millions of dollars a minute. And you're telling me, hey, open a ticket and give me this and give me that and let's work through it. And I'm going to escalate and get back. That doesn't work for OT. So they'll just say, forget it. We're going to do things our way because you just don't understand nor can support our environment. And then vice versa too. When the IT folks recognize that the OT aren't coming to them and they're just adding devices and rogue things to the network and just adding very cheap connectivity with no segmentation and no security, they're just opening themselves up to vulnerabilities and attacks. Yeah, very good point. So some 3 key security requirements in the OT space: identifying the devices. And as I mentioned, a lot of these IP-enabled devices in OT environment have really simple IP stacks. It's as cheap as possible that they add on. And sometimes IT comes in and says, hey, I want to identify this device or that device, and they do a port scan, and these things don't even handle port scans well, and they just fall over, and then they interrupt the line. And again, there's another cause for friction between the IT and the OT departments. The IT guys think they're helping, but they're actually harming when they take these devices offline just because they're trying to identify them. Well, we need to identify devices before we can do anything, set any type of policy, any type of protection. Operational insights is another area, and I'm going to give some examples of how the OT folks don't always know what's going on in the communication, the digital communications in their environments, and they really do need to have that kind of visibility. And then finally, anomaly detection. What has changed? So if something has changed or if there's been some sort of attack, to be able to identify that and then to be able to respond and enforce and to protect yourself against that. So when all these devices in an OT environment, basically all you know are the MAC addresses and the IP addresses. This is the administrator's view. So how do you apply policy to this? I have no idea what this device is, what that device is. Even if I have NetFlow, which are switches and platform support, well, I'll see that there's some communication between them. Which of these communications legitimate? Which of these communications indicate maliciousness or attacks or threats? Or what if they start sending data? If they're sending data to maybe the industrial data center, like we talked about in the Purdue model, they'll have typically a different data center from the IT one, or if they're sending things to the cloud. Manufacturers sometimes want their machines, their robots or whatever to send up data to their cloud so they can do diagnostics and monitor them. Which of these is a real legitimate flow? And which
the other thing on modern application in these times, you get a good documentation where you can build up policies. In this space for industrial documentation, often it's absolutely nothing with that you can work to build up a policy for that.
Yeah.
No, and in any case, even if you would have some information, you would then see that most of the devices not only connect out, but also between them. So it gets complicated to really build a profile simply because the possibilities are highly, just complicated. You can just talk laterally or horizontally, and you get to a point where what people was doing is just allow it any because it was simply easier.
Exactly. And that's what they look for, simplicity. And it's like we put everything in a flat network because that's simple. We allow any-to-any communication because it's simple. And they're thinking, well, we've got a firewall in place, so we're fine. Or, other insights, the OT people say, hey, I'm completely fine, I'm completely secure, but then when we go in and do assessments, okay, so many things aren't patched, or firmware is way behind, or DNS queries to, bizarre places, or unauthorized access. And all these things are happening, and they have no awareness. This is what we're talking about, operational insights. And I'll give one specific example. This is a large German auto manufacturer. So we went and we partnered with them, early field trial for Cyber Vision, and we brought Cyber Vision in, and we said, okay, we're going to sit and monitor your network, and then we'll give a readout and an assessment of what we've been noticing in your operational environment. And then one of the things that we noticed, we said, you know what, there's a PLC on your production line that was upgraded last night. There was a new program loaded. And they said, oh, absolutely not. That's a bug in your product. It can never happen. because we have policies in place. It can only happen during scheduled downtime, this, that, the other thing. Your product's just sending us on a wild goose chase. This is not real. He said, well, just out of curiosity, where did that upgrading come from? And then we said, oh, actually, it's from this IP address, which is outside your organization. They go, well, absolutely, then you're a bug, because we have a firewall in place. There's no possible way that external addresses to our enterprise can get in, certainly not access our PLCs. Absolutely, your product's complete garbage. We continued investigating, and what we found was that there was an OT technician who, after his shift at home, decided to make some changes to his programmable logic controller. And so he phones his buddy in IT and says, poke a hole for me in the firewall so that I can tunnel in and upload some new instructions to the PLC on my line. And that's exactly what happened. We were able to catch that and report on it, but the supervisor had no idea whatsoever that this has happened. And this is not even a malicious attack. This was a well-intentioned employee doing something they thought was improving, but because he didn't follow the protocol and the procedures in place, it's a complete surprise. And then the supervisor realized the value that this was bringing him. It's like, if this has happened, how many other things are happening that I'm completely not aware of? Just because I say don't do something, does that mean that everybody's going to follow that and respect that? And it's like, okay, these are the type of insights that we can provide with Cyber Vision. Okay, so let me get to a demo now. So what I have over here, I'm simulating an OT environment. In this case, something we're familiar with, especially those of us that have traveled from some distance and come by air. This is a baggage handling system model. So I'm putting in a bag, and then it goes through the system. But functionally, this is very compatible to any given OT environment. An ICS environment, because we have sensors, we have actuators, we have the whole system, and it's controlled by programmable logic controllers. And then all of this is monitored by our network and connected with our networking equipment, and our Cyber Vision sensors run right on our networking equipment. This is a huge value add, because other competitors in this space require dedicated hardware. And that's, doesn't scale well. You have to add hardware all the time through your network. Well, that's expensive. So you could either only put it at the, the aggregation level as it exits the subnet, but then only capture north-south traffic. But if you want to capture east-west traffic, you got to put in a lot of sensors. Well, you don't have to with us, because we just run it as a microservice on our switches, on our routers, or industrial compute systems. And so before having this type of abilities, we could see, okay, these networks in baggage claim, very large flat networks with no segmentation. Now these devices very often require maintenance. Like they'll have to call in a technician to maybe update the firmware on the PLCs, or maybe update the firmware on the robots. So bringing somebody in and connecting computers that are not within your IP domain or control, or pass all the tests, well, they could easily be infected by malware. And when they connect to your network, even though that might be air-gapped or firewalled or what have you, the malware introduced by these type of operations is very common, and in a large, flat, unsegmented network, well, you can guess what happens. As soon as one thing's infected, it can talk to everybody laterally and spread that malware throughout your org. Now, did you know that baggage control systems are the second most vital functions in an airport, second only to air traffic control? And if you lose your baggage control systems, we've had this happen at Vancouver Airport, where I'm from, they shut down the airport after a few hours because the airport just collapses under its own weight. When you cannot handle more bags coming in, they reroute flights. And so spreading this type of malware very easily can shut down an airport. And that's a lot of money, a lot of inconvenience, a lot of headaches and problems. So enter Cyber Vision. With Cyber Vision, basically all the information from these sensors that it collects by doing passive deep packet inspection. That's very important too to recognize. We're not spanning traffic, we're not replicating traffic, so we're not putting additional loads on the network. And because we're passive, we're not interfering in any way with the production environment. We look at all these conversations, we speak all the industrial protocols, we understand even at that deep packet level what's being said and what are the instructions being given, and then we report a summary of that. Between 1% to 5% of information is uploaded to our Cisco Cyber Vision Center. So for example, here in my baggage system, I can see all the components and I can have different views. If I'm an OT person, maybe I want to view all of these components according to that Purdue model, that industry level Purdue model, how it's laid out. So it's very OT centric. Perhaps if I'm an IT person, I'm more interested into having just a communication list. Okay, so in my baggage claim, what devices are talking to what other devices? And then any known vulnerabilities on any given device. Like I know now what every device is, so I have identified these devices. They're not just IP addresses and MACs. I know this is a Rockwell PLC. I know that's a Siemens DCS, or whatever the case may be. I've identified all of them, and I can identify, I know their make, model, serial number, firmware. If any of them have vulnerabilities, these are called out. And so I can click on any of them and identify the well-known vulnerabilities, and I can see what I need to do to patch them or to address them. And this is all then bringing all the best practices of IT security hygiene to an OT environment, something that was never ever present or available to them before. Not only that, but then I can monitor, and I can even do things like searches. Like, for instance, we worked with one company that, we said, well, how do you do your inventory? And it was a large US auto manufacturer. So they said, well, we're actually pretty good with our inventory management. We have 95% of all our devices in an Excel spreadsheet. So periodically, people update an Excel spreadsheet and they manually enter the device and the serial number and this and that. We're like, okay, well, that 5% that's missing, how many devices is that? And they're like, well, it's 6,000 devices, but for the most part, we know where everything is. Well, in Cyber Vision, you could just do a search, say, hey, 31.1, who's running firmware 31.1? And you know exactly all the devices and where they are on that particular software version. And then not only that, but I can then do baselines, taking a little while to load, but baseline network activity, and I can see who's talking to who, what kind of traffic is being sent, and I can even do comparisons. You could say, okay, in my environment, these are the flows. What are control flows? What are network flows, et cetera? And they can see all the devices, all the flows. And then as I compare from one point in time to another, I can identify what are the differences. So my operational insights now are being manifest. What has appeared, what has changed, what has disappeared is all being highlighted in this network view. And so whether there's a new component on my network, I identify that. Whether there's a new communication flow, I identify that. If there's even a new variable, that is like the example I used with a centrifuge, saying, okay, a well-known device that's allowed to talk to another device is now sending a new instruction, a new variable. That is even called out, and I can identify that as one of the variables if I have a variable change. So all of these levels of anomaly detection are available to me. Now, not only that, but then Cyber Vision doesn't keep this information to itself. We can export all of this to ICE, or to PX Grid, to ICE via PX Grid, or to StealthWatch via APIs or Firewall Management Center. Basically, any other, interested party can benefit from this information. It will then give them context. All they see is that source IP or source MAC address of a given flow. We can tell them now what that device is. For ICE, we can then take that IP and MAC and associate with a very specific scalable group tag. Now we're able to implement policy based on SGTs. And now we can do a lot of really good things. For instance, now it becomes easy to segment baggage claim system 1 from baggage claim system 2, so that, for instance, this sensor should never talk to that drive. Or, even if sensors are allowed to talk to each other or what have you, between cells, we can just cut down that flow. Macro segmentation to define the cells, micro segmentation that says within the cell who's allowed to talk to who, we can set these policies. And that's what I'm going to talk about next. Does that make sense before we shift gears? Okay, cool. So then, we have a much better, healthier environment here because we can use Cyber Vision to identify devices. We can use Cisco ICE and DNA Center to deploy very specific policies. Like I said, macro and micro segmentation. If there's malware detected, we can also send these alerts and basically react and adapt to what's going on rather than just let this type of thing spread throughout our entire network. Now, software-defined access. Are we all up to speed on SDA, or should we do a brief recap of some of the key components here?
Okay with it, but
Awesome. Okay, well then, I'm going to talk about, virtual networks are the mechanism that we use to do macro segmentation. That says, okay, this is, for instance, one cell, another cell, or a third, et cetera. We can just achieve that type of functional segmentation, or this is manufacturing, this is IT, this is another area, whatever, and they're completely isolated in private networks. Then within a network, we can also have...
Just to that point,
yeah.
The challenge is kind of, everybody's talking about microsegmentation, but if you have nothing, just flat layer 2, you need to start, yeah? So maybe you're getting more granular over time, but
yeah.
I think first general building blocks from macro to micro level, yeah? And of course, with the insight that you have,
yeah.
you cannot craft this all in one shot, yeah?
Exactly.
That must be done over time, yeah?
Very, very valid points. And so at the edge of a network, in a SDA network, you have a fabric edge node that basically encapsulates all the packets with a VXLAN header, and then within that, it has a virtual network identifier for macro segmentation and a scalable group tag for micro segmentation. Now, we had a tool, a mechanism called SDA Extended Node, which was targeted for IoT environments. These IoT switches do not have all the memory and all the capabilities. Even though they're Catalyst switches running iOS XE, their fabric edge counterparts, like a 92 or 9300, have extended functionality. For the cost and the price points that they need to live at, they don't have the same resources. So then, do you want me to go back? Okay. I'm going to share all the slides, and Brianna has them, but you'll have them as well. So what was SDA Extended Node? How did this work? Basically says, okay, we're going to then connect another switch to a fabric edge switch, in this case an IoT switch, like over there. That can achieve segmentation, macro segmentation, by having each interface in a VLAN that's been assigned by ICE, and then using a .1Q tag to maintain the logical separation. At this point, it's layer 2 segmentation. And then as it passes it up to the fabric edge node, that layer 2 segmentation becomes layer 3 segmentation, and you've maintained the separation. Lovely. Now, what it couldn't do is prevent communication within the virtual network between one type of device and another. So you couldn't do micro-segmentation within a switch. A fabric edge node could do this, but a fabric extended node could prevent it between switches, because basically then the path would go through a fabric edge node and be enforced at the egress interface. But within a switch, it couldn't prevent, say, an HVAC system talking to, in this case, a security camera. Well, you might have the requirement. In fact, it'd be a very healthy and recommended requirement to have microsegmentation between these types of devices, because if they're infected with malware, the first thing they do is going to say, who can I talk to? And where can I spread this malware that I have? So SDA Policy Extended Node, also released this week, 17.1.1, iOS XE 17.1.1. And basically, it then allows for even east to west microsegmentation, even in an IoT environment like a ring. And here's how it works. It uses a Cisco TrustSec metadata tag that's imposed And then that includes a field that contains the scalable group tag. So then here's how it looks. The original packet comes in. It gets not only tagged with .1q, but then tagged with CMD, and that includes the SGT, and then it's passed up. So you can enforce, even within the policy extended node, you can enforce a policy on the egress interfaces that prevents communication from one type of scalable group tag to another, depending on your policy definition.
Just to clarify, if I compare this with a classical ICE approach, yeah?
Mm-hmm. Yeah.
Let's say full-blown 3800, yeah? It will push ACL policies for every group, yeah?
SGACLs,
Yeah.
yes.
In this type, you're just transporting this to the policy extended node and enforcing the policy at that point, yeah?
Exactly, and the policy extended node.
Okay.
Yeah, but this allows for microsegmentation even within any of the devices
But you
connected.
don't need an, let's say, very expensive device where you can enforce
That's it.
ACL's
Right.
edge, yeah?
Yeah, because a fabric edge node has to have greater memory requirements and maintain the list mapping database and all these other additional functions, and we want to make that as lightweight as possible, because in these environments, they're looking for lightweight, low cost, et cetera. There's a very specific business need for the cost of the networking equipment that goes there, and therefore we have to try and match that need with the hardware that we supply, and then find an interesting way to achieve the same overall security functionality, but in a more efficient manner from a hardware perspective.
I absolutely understand the approach for me, but this will take a little bit more of load to the uplinks, I guess, yeah? If you device A and B connected to the fabric edge cannot no longer communicate directly to each other. It's always going to the policy extended node, and then traffic is traversed.
You mean like hub and spoke kind of fashion?
Sorry?
You mean like a hub and spoke kind of fashion, right? You go ups and
Yeah,
down.
if you enforce a policy on the right end, of course, when two devices connected to the fabric edge, they no longer communicate directly on that device, correct?
Sure they could, yeah. They could still communicate. You could have devices connected directly to the fabric edge, and that would enforce the micro and macro on them. Additionally, if you wanted to create an extended node, you wouldn't have to send traffic in a non-direct manner to achieve that. You could have all that micro macro policies enforced on the fabric edge as before.
Wow.
This is just additional functionality for a connected switch.
Okay, got it.
Yeah. Anyway, so some very important functionality there as well. That way it complements then, if we're able to identify these devices and then now share that with ICE, turn on, associate them with scalable group tags, it makes our policy expressions that much more granular and more effective, and our posture overall stronger. Now I just want to shift gears to edge data. So coming from security to that third priority of our BUs, and that's delivering edge value from data. There's real challenges here because we see that, okay, there's tremendous amounts of data to be had. Every organization undergoing digital transformation recognizes the value of data. The more you analyze your data, it's like crude oil, right? It's like you have a ton of it at its lowest form, but the more you process it, the more valuable it becomes. So you have your data, you take that in, you analyze it, you yield some information, you do some correlation, you get some insights, you learn from it, you could even do predictions. And this all becomes incrementally more valuable to the business. But to get all that data, say from an edge device to a data center, could be costly and time consuming, especially if you're trying to do things real time. If you got a low bandwidth link from a very remote location and you're just backhauling every bit of data that you have, it could take a long time, be very expensive, and then it becomes stale. It might not be that relevant by the time you've yielded a decision because it's taken so long. Another challenge is that you have a lot of different forms of data. Almost every manufacturer has got their own type of protocols and own structures. And so how do you normalize that so that you can start working with it? And then you might have to send data to different locations. Maybe you're sending to one cloud provider, maybe to the vendor, and so on and so forth. So there's a number of challenges into how we handle, and manage all this data. So with Cisco Edge Intelligence, which were also just released yesterday, basically these are the 4 key functions. We have pre-integrations with key data protocols, and we're going to continue to add to them: Modbus, OPC UA, MQTT initially. And so we know and we understand all these protocols, and we know the fields where the data is, and then we've already got integrations to grab that. We allow this data to be transformed any way you like by having, DevNet tools that you can write, scripts to say, okay, this is the data I want, and I don't want to just, for instance, grab all the temperature data all the time, but only if the temperature is above this threshold, then send me something. You can do this type of transformation with that data. Then, also having governing policies, because maybe you have regulatory restrictions onto where that data can go, or you just have, privacy policies that are going to govern where I'm going to send that data. Sometimes you might send it all to a cloud provider. Sometimes you might filter it and keep proprietary data for yourself and send that to a local. Whatever the case may be, you have some challenges there. And then finally, the delivery. And so we've already been pre-integrating with these Azure, MQTT, and we're going to continue to add. So basically, here's how it works. So let's say we have all these different types of devices, robots made by ABB, some systems by Siemens, et cetera. We ingest this data because we speak these protocols, we understand them, and then we can extract the data from the various fields because, again, we have all these pre-built-in integrations, and then we allow that to be transformed. So you can write whatever detailed requirements, you just write some scripts using, like I say, these DevNet tools that we've made available. It becomes very developer friendly, what to do with that data and how often to collect it. And what do you want to use a threshold or compare only if this event happens with that event, then take this step. You can write all that logic according to your specific considerations. And then this is across the board. So not just one type of device, but all these different pre-integrations that we already have that we're going to continue to add to, all being ingested, all being transformed. And then you can define your governance policies that says, okay, maybe I'm going to send all my data to this cloud provider. For this specific type of manufacturer, I'm going to upload that specific data because they might want to keep track of their machines or, for diagnostics or maintenance reasons. And then you can specify all of that. Cool. So then here's our Cisco Edge Intelligence tool. And this is what it looks like. So again, Edge Intelligence is a microservice that can run on our network gear again. So again, that makes everything far more scalable. It runs in IOX on these platforms. And then we define the different devices. In this case, we're saying, okay, we've got a baggage controller PLC. We can define the various types of destinations to say, okay, there's multiple places where we might choose to send data. I think I've timed out, but let me try to refresh. Okay, bear with me while that comes back. So you can define, say, hey, Azure is one destination, or maybe this service contractor company that I have is another destination. You define those destinations, and then you build a pipeline. And when it comes back, I'll do that. That says, okay, from this given destination, this given source, where do you want the traffic to go? So for instance, here, I've said, okay, from one of my PLCs that I have on my airport baggage system, send that information up to Azure, but MQTT traffic from that PLC, I might want to send instead to a baggage service company so that they can keep track of that. And then I just deploy that just by a few clicks. I select the devices, the network devices I want to deploy it to. And then in the end, I can then monitor, and here's data being sent from my devices up into one of my, basically a digital twin of the airport PLC, so that it's getting that data and then it's monitoring it in real time, analyzing it, hopefully able to prevent, I could do all sorts of things with it from that point. Like, especially preventive maintenance is one of the biggest attractive goals of data in IoT space, especially OT environments.
It would allow you to extend the lifetime of all these devices.
Exactly. And if I don't, because the OT people, they know we have to do preventive maintenance every 6 months. So sometimes they're like, okay, we didn't find anything wrong. Well, then did we have to really take down the line, or we could have ran it a little bit longer? You know, so if you have the data that says, okay, we know that before a thing fails, it starts to vibrate like this, or you see indicators like temperature like that, or whatever the case may be, then you say we could potentially run the production line longer until we see those failures, and then preemptively take it down just before it does fail, and then allow for that more effective production to continue and things like that. And so this is how it can be achieved and simplified. So that's what we're sharing here. So then, coming back to this example, as we've been showing, returning to our baggage claim example, but in this case from the perspective of Edge Intelligence. I'm gathering information, you know, in real time, monitoring vibrations and temperature, motor RPM, and then I'm sending it to multiple sources. In this case, I was showing the service company dashboard, but I'm also sending it at the same time up to Azure. And again, I'm taking it all from the networking gear. I'm not adding additional network hardware or additional complexity into the systems. I'm trying to leverage the compute that's already available from the microservices platforms on our networking platforms, so that we can just leverage those to process this edge data as efficiently and cost effectively as possible. So the key takeaways I want to leave you with: OT attacks, relatively new in the past decade, extremely expensive, extremely real threats, because these threats are now coming from the digital world and affecting the physical world. And in companies where you take out production lines, that's where they hurt the most. Ironically, these areas are also the least defended, because they've been running in a certain way for decades, and they've never had these kind of threats to deal with or take into consideration as they design the systems. And as such, there's very little preventive mechanisms in place. Plus, there's a mindset thinking that, hey, we're safe because we got a firewall, or because we're air-gapped, or whatever the case may be. But as we discussed, a lot of these preconceptions do not align with what we see in reality when we do our network assessments. Cisco Cyber Vision, 3 key functions that it delivers: device identification. If you don't know what your devices are, you can't apply any form of policy. So by giving that key insight, that allows you to start with your policy creation. It provides operational insights as well. The example of the auto manufacturer that didn't even know that PLCs were upgraded by an employee at home. Well, what else is going on in your network that you're perhaps not aware of? We can show you, hey, are there new devices? Are there new communication flows? Even new variables introduced in legitimate parties, machines that are communicating, but they're doing so in a different way now. You have to be aware of that. It scales with the network. That's a really key, one of the best value propositions, because every other vendor that offers something in this space requires dedicated network sensors to be put in. But because we have a lightweight sensor that we can run in IOX on our networking platforms, it makes it very scalable. And the more scalable it is, the better the overall effectiveness of the solution. You're not missing traffic. Like if you would only span or sense at a north-south interconnection node, you're seeing all the traffic, all the east-west as well as the north-south traffic. And we don't keep this information to ourselves, so very much in line with our multi-domain strategy. We share that information, PX Grid, we share it to ICE and extend that to DNA Center. We share it with StealthWatch, share it with Talos, share it with Power Management Center. All of this information then can help enrich and increase the effectiveness of all these other domain controllers and management tools. And to complement this, we saw that there's new functionality in SDA that now allows us to do microsegmentation, the policy extended node. That was never previously possible with the the extended node function that was previously available, now policy extended node versus extended node, allows us to do this. So again, some very critical functionality to prevent that spread of malware in these type of environments. Very, very valuable. And then finally, we talked about edge intelligence and how we can simplify gathering the data, transforming it according to your specific environments, governing what data goes where, and then very simply interconnecting, and then you can have that data flow happening, and then take advantage of the compute resources that are available in your networking platforms to do as much local analysis of that data as possible, which increases the relevance of the data, and it increases the real-time effectiveness of it, and lowers your bandwidth costs, and many other advantages. So these are the things I want to share with you, advances in IoT, predominantly in cybersecurity, and also in edge intelligence. Any final questions? Or yes, please.
I have one question.
Yeah.
How is it for you with different industries? So I was working in consultancy sometime, and what was amazing for me, if you go to a different industry, so you mentioned automotive industry,
Yes.
they have kind of common things that they use, and you maybe see the same protocols no matter if you go to vendor A, B, C, I don't know, I guess they have similar, let's say, infrastructures, yeah? But if you go to a completely different vertical, I'm making something up,
Yeah.
the milk industry, yeah?
Yeah.
They're using different industrial machines, and maybe you see completely different stuff. So for me, I think it will be also a challenge to get all the industrial protocols in for all the different, let's say, vertical industries, yeah?
Yeah, that's a very valid point. And so Cyber Vision is very analogous. I'm coming from an EN background, as most of you are aware, and I've done a lot of work for a lot of years with AVC technology, application visibility and controls, where we would support, they're supporting over 1,400 applications to recognize them, but they continually add to that. So they can, have signatures for new applications and new protocols. Cyber Vision is very similar. So we've started with all the major industrial protocols, the ones that are most common and across most industries, but we're going to keep on adding to that library so that we can do the deep packet inspection and understand the structure. And the more of these customer requests we get, I say, okay, let's go after that. Let's keep adding. So that's the direction to address the concern that you just raised. Okay, if in the milk industry there's a protocol that we don't support and we have some big customers that say, hey, we want this, it's like then the PMs will make a call and then direct the engineers to do the according research and development.
So with this modularity, it's not so hard for you to implement more protocols?
Absolutely, yeah, it's exactly, and it's very much intended to be ongoing, adding to this library.